My name is Diego Lizárraga, and this is Hope for the Future, because that is exactly what we want to create. In this short film or documentary for Introduction to Statistics and Trigonometry, we're going to talk about all the process in matter of research and effort-wise for the model to create the International Youth Fellowship Children's Lodging. Hope you enjoy.
The selection of 3 sustainable buildings in our assigned country are solar panel. Mitsubishi Electric Corporation is a Japanese multinational electronics and electrical equipment manufacturing company. In this case, the analyzed building is the Hercules in Tokyo, Japan. This building uses solar panels to convert solar energy into electricity, used in lighting systems and in some machines engines. We choose this because it's a perfect example of how we want to use solar panels in our building. The second one is wind power. There are no current buildings that use this energy. However, Sena Systems are working on a new type of generator from wind power. It is 15-meter tall hexagonal building that compresses wind from all directions and routes it through generators. This is planned for desalination plant and a visitor center. However, these are a lot of wind farms all across Japan. These farms consist of humongous chargings and machinery that generates, stores and transforms the kinetic energy from the wind to the electric. We choose this because there's a lot of wind energy in Haiti and in Japan, and they're used commonly. The third one is the geothermal power. The active volcanoes in Japan are the primary generators for geothermal energy. The amount of electricity that could be generated is equivalent to 23,470,000, which is equal to the energy consumed by 40 million households. Yet only 2% of this energy is actually used for energy because of the process of compression from geothermal to electricity. There is no building that produces this energy and also uses it. However, there are over 20 production plants in Japan. The most important ones are Matsukawa and the Hachobaru geothermal power plant. We use this building because of the amount of people that get employed in the extraction of geothermal energy. There are more than 20,000 people that are involved in geothermal power.
Hi, my name is Edgar Echeverria, and I will explain a little bit the 3 buildings that we based our building and why we choose these buildings for this project. The first one is about solar power, and it's the Mitsubishi Electric Corporation headquarters. Mitsubishi is a Japanese multinational electronic and electrical equipment manufacturing company, and in this case, the analyzed building is the headquarters in Tokyo, Japan. This building uses solar panels to convert solar energy into electricity used in lighting system and so machine engines. We choose this because it's a perfect example on how we want to use the solar energy in our building. The second one is about wind power. There are no current buildings that use this type of energy. However, Sena Systems are working on a new type of generator for wind power. It's a 50-meter tall hexagonal building that compresses wind from all directions and runs in through generators. And this is planned for a desalination plant and a visitor center. There are lots of wind farms all across Japan. These farms consist in human-use turbines and machines that generate, store, and transform the kinetic energy from the wind into electric. We choose these ones because there are a lot of energy, wind energy in IT, and in Japan is uses commonly in different buildings. And last but not least, the geothermal power. The active volcanoes in Japan are the primary generators for geothermal energy. The amount of electricity that could be generated is equivalent to 23 million kilowatts, which is equal to energy consumed by 40 million households. Yet, only 2% of this energy is actually used for energy. Because of the process of conversion from geothermal to electricity, there's no building that produces this energy and also uses in a correct way. However, there are over 20 production plants in Japan, and the most important ones are the Matsukawa and the Hachobaru geothermal power plant, which is this building because of the amount of people that get employed in the extraction of geothermal energy. There are more than 20,000 people that are involved in geothermal power, and the crisis that IT is living since the earthquake that get affected for all people, for all the people, for all the population in IT. I think it's a good help for these people to get a better I don't know, well-being or something like that. So, well, this was our 3 buildings. So continue seeing the rest of the project.
Hi, my name is Romo, and I'm going to explain you the theoretical framework. This is the research and certification of the country where the new sustainable building will be built. Okay, I'm going to explain this so you can understand me. The chosen country to research about is Princeport or Port-au-Prince, the capital city of Haiti. All the sustainable buildings come with either solar panels or water redirectioning, meaning the water used for plants, cooking, and other domestic and industrial matters goes through the process in which the water is cleaned, warmed up, and stored. This means that all the buildings use the solar energy and the water plants to do the domestic activities, how I already said. Okay, we're going to continue. The sustainable buildings are very common in Haiti. Most of them owned by U.S. architectural firms. We took a lead on Project Haiti. The architectural firm HOK, H-O-K, is in charge of this building. Since an earthquake hit Haiti in 2010, the firm started working on a sustainable design for an orphanage and children's center in Port-au-Prince, the capital city of Haiti, as I already mentioned, which includes natural ventilation, self-water supply, power generator that uses solar, wind, and biofuel processing. This is a goal for our design because it uses all resources possible, and the main focus is to give hope and lodging to the children and in the orphanage. Thank you for your attention. My name again is Romel, and now I'm gonna explain in the detail the type of sustainable energy that was selected for the construction of the new sustainable building and how the natural resources of the place where the new building shown in the model will be hypothetically used. Okay, this will be solar and hydropower. As an island, Puerto Principe get the UV rays from the sun in a bigger way. What does it mean? That they have machines and solar panels that capture the sunlight and convert it into energy. This process should be made by panels in the top of the building. They are not going to be in the ground or in the parks or something like that. They have to be forced in the top of the building so they can get more UV rays. The water as a resource is not a problem either. This process should be created by underground plants to transform the water. The water as a resource is not a problem either. This process should be created by underground plants to transform the water into energy and big equipment to produce the energy of the water into electricity. What does it mean? That, for example, the buildings that are near the ocean are going to work by hydropower energy. That means that they're going to have plants under the ground and the sea is gonna hit the motor, and that will create kinetic energy, and that will be changed into electric energy to cook, to take a shower, to make domestic things. And this is good to the planet because it helps to the pollution problem. Thank you.
Our conclusion is that the project was quite easy and the research was the easiest part due to the tools we had, internet, computers, etc. The creation of the model was quite challenging because the lack of communication between the team. We could have done a better model, however, we gave our best effort. We were able to introduce the system energies using the natural resources of the place we chose. And we complete the small and big research. The trigonometric radius were used without major complexity. We have practiced them a lot and they were really simple to use. In real life, Architects and engineers use them practically on a daily basis since their work consisted of estimating distances, amount of materials, angles for supports, and angles that are aesthetically acceptable. Sustainability in the future, eventually fossil fuels will disappear and we will now to spend completely on renewable resources. Using natural resources without concern is also a problem because they can make a global problem, like global warming, and there's a lot of negative effects on the world. It is important to know how to use them enough to survive and keep on doing daily activities. However, we had to also learn how to maintain a balance with nature and avoid abusing of natural resources.